In this video, I'll be going over how to set the ESP32 up in a voltage divider circuit and how to collect data. We want to set the ESP32 up in a voltage divider circuit so that we can get a correction factor for the ADC that is in the ESP32. We've gone over the ADC in the previous video. If we get data for the voltage at each branch of the voltage divider circuit, and then compare that to what the voltage should be, then we can get a correction factor for the ADC that is inbuilt in the ESP32. We calculate what the voltage should be using the voltage divider equation. I'll switch to another camera to show you how to set up the ESP32 in a voltage divider circuit. This is our ESP32 in a breadboard. Strongly recommend that you see the breadboarding series before you watch this video. We have 3 wires connected to the ESP32. We have the black wire connected to the 3.3 volt pin. We have the orange wire connected to the ground pin. And we have the red wire connected to the IO1 pin, which needs to be noted for our Arduino code later. We need to set up our voltage divider circuit, and for that we need another breadboard. We also need resistors. I'm going to be using 5 resistors in this voltage divider circuit, but this will only give you 5 data points, so you need to use many more when doing this yourself. I'll show an example with 20 resistors later. We have to measure the resistance of each resistor using a multimeter and record this and in which order the resistors have been placed in the circuit. This is necessary for the Python code that will be covered in the next video. I've got my 5 resistors that I'll be using in this circuit here. And I want to record the resistance across them using a multimeter. And the way we do that is we take our multimeter here and we put it to resistance. So I know from the packaging that this will be about 510 ohms. So we'll put it to 2000 ohms to measure 2000 ohms. And then to measure the resistance of the resistor, just put the 2 prongs at either side of the metal spikes. And we'll get a resistance about 507. So note that down, and then note the order in which you've placed these resistors. Now we put each resistor into the breadboard, and we want to do it at a slant so that we can create a voltage divider circuit. So we put our first one in. We can put our first one in normally, and then our second one, we want to put in a bit of a slant. The first column here, where 2 prongs of the resistors line up, will be our first branch in the voltage divider circuit. And we can measure the voltage from there. And that is our voltage divider circuit. Make sure none of the metal in the resistors is touching, otherwise that will ruin the circuit. To set up the wires in the voltage divider circuit, you want to take 3.3 volt pin, so our black wire, and put it here. And then you want to take the ground wire, the orange wire, and put it at the other end of the circuit. And then our red wire can be used to measure the voltage at each branch of the voltage divider circuit. So if I put it here, it will measure the voltage across these last 4 resistors. Put it here, it will measure the voltage across the last 3 resistors, and so on. You will need to measure the voltage across each branch of the voltage divider circuit using a multimeter, which will be necessary for your Python code in the next video, because you'll want to compare it to the calculations using the voltage divider equation. To do that, you get your multimeter again, and instead of being on resistance, you want to switch it to voltage. So switch it to measuring 20 volts, and then you can put the spokes, the metal bits here, right in the hole where the metal part of the resistor is. Put it on one side and then you can put it on the other. That reads 3.30 volts. You need to record that because that is going to be the measured supply voltage. You always want to measure the supply voltage because even though the ESP32 says it's going to be 3.3 volts, it's not necessarily accurate. Here it is 3.3 volts, but it might be 3.29, 3.28, 3.31. So make sure you measure it. And the way I measure the voltage across the last 4 resistors is I just put my spoke in the metal part of the second resistor. So 2.64 volts, and then I can record it for each different resistor in that same way. There you are. A 5 resistor voltage divider circuit will only give me 5 data points to plot on a graph. This isn't that many to create a line of best fit with, so we want to get more data points. And the way we do that is with a larger voltage divider circuit with more resistors. This is one I made earlier, and it has 20 resistors in it. It does look a little bit daunting, but don't worry, you make it in exactly the same way as the 5 resistor circuit. You just need to make sure you measure the resistance across each individual resistor and then record where that is in the voltage divider circuit. It also works the same way with the wiring. So if you take your 3.3 volt wire, put it in exactly the same place, take your ground wire, orange in this case, put it in exactly the same place, and then you use the red wire, your data wire, in exactly the same way. You just put it in each branch of the voltage divider circuit. So branch 1, branch 2, branch 3, so on and so forth. Make sure you measure the voltage across all the resistors, which will be your supply voltage, and make sure you measure the voltage at each branch of the voltage divider equation and record it, because once again, it's necessary for your Python code in the next video. I'll be switching over to Arduino IDE now so that I can show you how to collect data from each branch of this voltage divider circuit. Hello, this is the code for collecting data from each branch of the voltage divider circuit. It's not too long, but it's a little bit complicated, so I'll go over it. The purpose of this code is we want to collect 101 data points from each branch of the voltage divider circuit. We then take these 101 points, and then in Python in the next video, we'll average them and plot them. But here, we just want to collect those 101 points, and then we want to stop collecting data for a little bit of time. And then after that time period, we collect another 100 points in a different branch of the voltage divider circuit. So in that time, in that interval, we need to change the data pin from one branch to the next branch. Start here, integer I equals 0. This is like our counter. And then void setup is very normal. Seared up again. You can do 9,600 if you want, but we've done 115,200. Analog set pin attenuation. This sets the reference voltage of the ESP32 to whatever 11 decibels corresponds to. Here it will be about 2.89 volts. You'll need to make sure you measure this. We measured it using a power supply, and this was covered in the previous video. Into our void loop. So if I is less than or equal to 100, this will give us 101 data values because we start counting at 0, remember? Float sensor value 1 equals analog read 1, 0.print ln sensor value 1. This will just print the digital reading that the ESP32 is getting from its ADC. I++ adds 1 to our counter, and then delay 50. This means there's a 50 millisecond delay between each of our 101 measurements. So it'll take one measurement, 50 millisecond delay, another measurement, and so our 101 measurements will take about 5 seconds to record. Else, 0.print ln line. What this will do is after 101 measurements have been recorded, it will print line, and then it will leave it for a delay of 8 seconds. So we'll have 8 seconds to take the data pin out of one branch and then move it to the next one. And then this will set I back to 0 so that we can go through this if-else statement again and record another 101 data points. Because the reference voltage of the ESP32 is about 2.89 volts, the first couple branches will just read 4095. They'll just saturate. This means we'll have to cut them off in the Python code in the next video, but that'll be explained to you, don't worry. I'll give you an example. I'll show you us collecting data from a couple of branches in the voltage divider circuit. So if I select a random branch here, then I open the serial monitor. But before I open the serial monitor, I want to make sure I've selected the right board here. So you want to select ARM2M core ESP32C3. You do that by selecting other board, and then search board, you just type in AIR, and then you select that one, and then select whatever column is available to you. So for me, it's this one here. And then I open the serial monitor. It's printing about 3,390. Then line, so I want to take it out of that branch, put it into the next one. Wait a few seconds, and I'll print about 3,159. If I put it in the first branch where the voltage in pin is, where the 3.3 volt pin is, it'll just print 4,095, just be maxing out. If I put it in the next pin, it should give me exactly the same thing. Exactly, because it'll be about 3.1 volts here, but it can't tell the difference between anything above 2.89 volts. If I put it in the very last branch next to the ground pin, yeah, about 0. Because we're next to the ground pin, there's no resistors there, so there'll be no voltage that's being recorded. Great. That's it for this video. In the next video, we're going over the Python code for this data and how to plot it and get a correction factor for the ESP32's ADC.